Hello and welcome. In today's video, we're going to be exploring nornir filtering. We're going to take a deep dive into nornir filtering and see how powerful this tool is for you and for your network automation endeavors. In today's demo, we're going to follow along with the repository that will be shown in the YouTube link. And in today's video, we are going to go through 3 levels of demos. We'll firstly start out with nornir basic filtering, where we only filter on one aspect at a time. Then we'll move into intermediate concepts, and then finally round out with some more advanced filtering. All of today's demos, as mentioned before, are inside this repository shown up the top, and each demo is meant to be what is called a canned demo. That is, all the commands, requirements, and dependencies are contained inside each folder. We will also touch briefly on another tool called motherstarter, which we'll use to dynamically generate our inventory. So let's move over to the code. In today's video, all we are going to do is display our filtering results to the screen. We won't be connecting to any devices, but hopefully those concepts are covered in other videos which are freely available on the internet. So in today's video, each time that we execute a filter, that filter and some additional metadata will be displayed to the screen. Okay, so let's get into it. First, we're going to start out with the basic demo. And inside this basic demo, we'll first talk about the inventory that we're going to use today. So if I go into this inputs folder, I have 2 files called inventory.json and groups.json. This structure is replicated across all the other demos. If we firstly have a look at our inventory data, you can see we have the name, management IP, vendor, and operating system for every one of our hosts in our inventory. In the groups file, we have a couple of groups in here, and they all seem to be loosely based over operating systems. In terms of a normal starting out in nornir, this is typically what we see, where people have the absolute minimum amount of data needed to actually connect to devices. So firstly, what we're going to do is translate this data from this JSON format into a format that nornir knows and understands. And in order to do this, we're going to use a tool called motherstarter to convert our data for us. So what we are going to do is convert this data, and the source directory for our data is this inputs folder. And then we have a templates directory over here. Our source type is a JSON file, and our output is nornir. For those of you that don't know what motherstarter is, it's a data transformation tool that can take different file formats and output it into other different file formats for use with various network automation systems. So let's quickly have a look at the templates for this basic demo and have a look at what we should anticipate to see out the back of this transformation. We open the templates folder. Each folder has 2 templates, one for the host's YAML file, which we're going to generate, and one for the group's YAML file, which we're going to generate. So if we have a look in here, it looks like we're going to end up with a host name, each device in a group, which seems to be after the operating system, some custom data, which is under this data key, and we're going to have a management IP and a vendor. Okay, now let's execute the data transformation using motherstarter. Okay, that's done now. So it is reported back to the screen which templates that it's used, which template directory it's used, the source type, the source directory, and the output type. And then inside here, it is reporting the file output location, which if we go over here, is motherstarter outputs nr inventory. And within here, we have a groups.yaml file, which if I bring up the template on the right-hand side, called the host.j2 template, you can see that we end up with the data that we should as a result of the template rendering. And if we scroll down, we can see that that's consistently applied. Let's have a look at the groups Ginger2 template, and then let's look at the groups.yaml file as well. Okay, and again, we end up with a very similar data structure. So again, we have this custom data called vendor under the Junos groups. Okay, so now that I've explained how motherstarter works and how it translates data, we will move past those aspects a little bit faster in the preceding code. Okay, now let's look at the code that we're going to run for this demo. And basically, all we are doing here is initializing nornir using those templated files. And then we have a suite of functions listed out here. And then at the bottom, we have a way to toggle functions off and on so that we can see the results. So first things first, what we're going to do is just display the inventory to the screen. So we will run the Python file. And we're just using Colorama to colorize our output so that we can see the interesting data. Apologies about that. Didn't save the file, so I'll run it again. Okay, so we have a look over here. I'll just adjust this window slightly. In a display inventory function, we're essentially iterating over the hosts in the inventory, and we're printing out a host string and then the actual host, and we're doing the same thing with the inventory. And as you can see here, we have 18 hosts in our inventory, and we have 6 groups in this inventory. So at this stage, we're not actually filtering anything, we're just displaying the inventory. Next, in order for us to actually understand what it is that we can filter on, we need to be able to display what values are available for us to look at. We can do this one of two ways. We can look at the data structure under here, under each host, and look at the groups.yaml data structure and adjust our filters accordingly, or we can use the host dictionary option within nornir, which is shown here. So we can just filter our host, filter the inventory based on our host, and then we can do the .dict function, and we can print that information out to the screen. So let's have a look at that now. Okay, so on the screen we are displaying information for host, and we've got the name of the host, its groups, and then what appears to be the custom data under that host called labarista1. We also have the host name, and we also get some other values as well, namely the port, username, and password, as these are uniform things applied to every nornir inventory. And then we also have the platform EOS defined. So if we go over here and look at our groups file, you'll notice here, if I look for lab arista01, which is here, we haven't actually defined the platform here. And what's actually happening here is the platform is being inherited from the group. So the platform is EOS here, and the group is EOS, and we are inheriting that. So using the dict function allows us to see what data is on offer and what we can actually filter that host value with. Okay, let's turn that one off, and I'm going to turn the display inventory one off now. And now let's have a look at some group dict data, which works in a similar way to the host data. So over here, again, we are filtering the inventory by a certain group, and then we are just printing out the dictionary. Okay, let's run this now. Apologies, didn't save it. Okay, so now we are displaying the information for the group. And as you can see in here, we have the name, We have some custom data called Cisco for iOS. Obviously, we don't have a host name, but we could. Port, username, password, groups. So it's the same structure, whether it's a group device, a group object, or a host object. And just to show the differences, we have another group called NXOS SSH. It has a vendor of Cisco and a platform of NXOS SSH. So now we've seen how to display things. Next, what we're going to get into is actually filtering. So the first thing we're going to look at is the filter host vendor. What I'm going to do is I'm just going to split the screen here so that we can look at what we're going to pass into the function and look at how the function works. So these three filters that we're going to show in this particular part of the demo are just the basic filters in nornir. They are effective to a point. They do have their limitations. If you're looking to use very simple ways to filter your inventory, they're certainly effective. So what we're going to do firstly is we're going to run filter host vendor, which is basically going to take a vendor passed in at the top of the function and filter all hosts that equal that vendor. And then it's going to print the host to the screen and the vendor. So let's run that. Okay, so as we can see here, it's printed out for Arista devices. Okay, same deal with iOS. Again, it's printed out some iOS devices and the platform as well. And finally, we can do things like filter on custom data. So management IP isn't a predefined property. It's a piece of custom data which we are going to filter on. Again, we're just going to filter based on the management IP, and we're going to print the host to the screen and the management IP. So we run that, and obviously there's only one device with that management IP address. So that concludes basic filtering. What we've seen here is that we can filter by one property at a time, and it works to a point and allows us some levels of filtering. Okay, now we're going to move on to intermediate filters. In this part of the demo, what we're going to talk about is the way to use one filter at a time, and then also a way to what I call chain or join together filters to get more contextual results. So firstly, what we're going to do is just have a look at our inventory this time. And now you'll notice that compared to the original demo, we have some additional metadata in here about the device. We now have operating system, environment, and device type. And we've got a lot more devices. I believe we have 27 devices in here. In addition to this, we also have some additional groups. We have some groups which appear to be based on environments, and they have certain values set on them. So there's a group named lab. We have an SLA value of 70 and a production Boolean set of true or false. Just having a look at the templates here. So we are also doing some conditional logic within our Ginger 2 templates to find lab, prod, and test, and to run them through a certain filter, and then all the other groups run them through a different filter. If we have a look at the hosts Ginger 2 template, we can see in here now we are capturing additional devices. This time we have two groups. We have the operating system, which we saw in the basic demo, and now we also have the environment. So again, as per before, we're firstly going to run motherstarter to convert our inventory into the appropriate file formats. And that's run now. So if we have a look in here, again, we can see we've got additional data to work with, and we've got additional groups to work with. So as per the first demo, what we're going to do is we are going to print out, I'll print out a few of these at the same time. We're going to display the inventory, display a host dictionary, and a couple of group dictionaries, and we'll go through the results. So let's run the Python script. Okay, so let's scroll back and start at the start. Now we have 27 hosts in the inventory as opposed to 18 in the original, and we have 9 groups in the inventory as opposed to 6 in the basic demo. Now, if we have a look, we have a lot more data to work with, which is being reported back using the .dict function. So we have an additional group in here and some additional properties, namely the device type custom data, which we can print about the host. Not too much has changed in terms of iOS and NXOS, but if we were to change this group to say test, run the code again, I'll turn off these as well. Okay, so under test, we have some custom data, SLA equals 80 and production equals false. So this is where motherstarter becomes effective because you can cut your data in whatever way you want, just using Ginger 2 templates to get whatever structure that will work for you and your needs within inside your organization. Okay, one thing that I'd like to add is as we go through these demos, all the code contained in the previous demo is still contained within the file. So when you get to when we get to the advanced Python file, it's going to have all the functions that we've seen today in the file. When you look at the advanced one, this one will have the basic ones in here as well. The idea of that is, if you want to compare how we started out versus how we got to at the end, you can have a look at all in the 003 file. Okay. Again, what I'm going to do is I'm going to split screen this and bring up the code on the other side so we can have a look at the function inputs and the function itself. So in the intermediate offering, what we're going to do is we're going to start to look at some of the other things that are on offer with nornir. So we can do this thing, which I like to refer to as chaining or joining multiple filters together. Again, using the basic filter to filter for more nuanced results. So in this particular function, we're going to filter for a device type and a vendor. So if it matches both, it will be printed to the screen, and also we will print out the device type so that we can see that it's correct and the vendor. So let's give that a go. I'll just turn the display data off. Okay, so we can see that we fed in a device type of switch and a vendor of Juniper, and we've got 3 results. So again, we can, moving down to the next function, we can, continue to add as long as they equals. So everything has to match. So in this one, we're going to look for a device type of switch, the vendor of Juniper, and management IP of 10.0.0.23. Okay, obviously there's only one result, but you can see the values to the screen. Okay, now what we're going to do is in this particular function, we're chaining 3 functions. We're chaining essentially 3 filters together within inside one function. And now what we're going to do is start to take the output of, say, function 1, and then take that data and put it into another function. So firstly, what we're going to do is we're going to run this filter vendor function. So we're going to filter everything based on Cisco, and we're going to assign it to the Cisco devices variable. So let's do that. And we've got our results back. And now what we're going to do is we're going to go through the filter device type function. And what we're going to do is we're going to take the output of this function, filter vendor, and we're going to feed that inventory into this function. So we're effectively doing the same thing as we're doing here, but we're doing two different functions. So that allows us the ability to keep our code modular and reuse functions and chain them together in whatever format we needed. So let's run that now. So the first results are Cisco. Then it's run through the device type equals router. So we're taking the output of this function and we're passing that variable into this function. And as a result, we can filter the first filter for Cisco devices, then the second filter for routed devices. So the output of this would be Cisco routers. There's a typo there. Okay, let's have a look. Let me just quickly fix that. So obviously we can do the same thing again now. Um, Obviously over here we're still using Cisco devices as the input for the inventory to be filtered on. However, this time we're just looking for switches instead. So let's comment out this function and run it again. So by having it in this way, what you could do potentially is write Python functions for each type of filter that you wanted to use, and then you could chain the results together out of each one. And then depending on what your use case is, you can reuse the functions and just basically write the workflow logic as I've done below here to get what it is that you're actually after. So finally, just to show that this works, my inventory doesn't contain any Cisco firewalls. It does contain Palo Alto firewalls. So to prove that this works, what we will do is filter for firewalls, and obviously we have 0 results. So in the second set of demos here, we've seen how to use filters at an intermediate level. We're still using the basic filter, but we've seen how we can filter for multiple properties at the same time using one function, or maybe make it a little bit more modular and filter for one property at a time, but take the outputs of those functions and feed them into other functions. Okay, we're up to the last demo in this deep dive, and in this demo, we're going to cover some advanced concepts. So firstly, let's introduce our inventory and groups JSON source files and have a look at what's going on there. And what we can see now is that we've added even more metadata than last time. We have a site code now, and we have what seems to be an OS version. Uh, with this demo and all the other demos, the actual data doesn't really matter that much. It's the purpose of seeing the filters in action. So don't really worry too much if some of these aren't really logical. But basically we have a whole bunch of site codes in here, different different OS versions and different properties. So now let's look in the groups.json file. We'll put it on the right hand side of the screen. So we have the standard groups that we've seen in the previous two demos. We have our environment groups that we've seen before, and now we have introduced some new groups. So these groups are based on physical sites or site-based group data. So in here, what we have is a site code, full name, country, region, hemisphere, and the premise of site type. So with inside here, what we're going to do is we're going to start to use some more and more metadata, and this is going to help us really highlight the power of nornir filtering. So again, if we have a look over here at our groups file, I'll just bring up the groups.json file here. Again, there's some Ginger 2 magic going on in here, but basically what we're going to do is render out those specific values and show them in our groups.yaml file. And again, if we have our inventory.json file on the left and our host.hostginger2 file on the right, this time we're adding a third group. So we're going to add a site code to every device. And we're also going to print out the OS version and also the site code as some custom data. So again, as per the last two demos, let's go ahead and convert our data. Okay, cool. So now let's have a look at our host.yaml file. So again, we're really starting to enrich the metadata that we have about a device, and you'll see the benefits of that shortly. So in here, we've got some devices in Melbourne, Barcelona, um, Montreal, and I think Port Louis and Christchurch as well. So we've got a whole bunch of devices in here. If we have a look at the groups YAML file, again, we have the structure as before, and we also have some custom data under each of our site codes that we will be able to exploit with our filtering. Okay, as per the last two demos, what we'll do is we'll split screen the code so we can look at the filters and we can look at the code at the same time. Let me just scroll down the right hand side. Okay, first things first, what we're going to do is we're going to follow what we've done in the first two demos, which is to print out the inventory, some host dictionary data structure, and three groups so that we can have a look at those. So let's run that code. Okay, let's scroll back through. So again, as we can see, we've got a lot more data that we can target or exploit for filtering at the host level. And then at the group level, both iOS and test are exactly the same as what we've seen before. But now under port PTL site code, we have, the name of the site, which is Port Louis, the country, Mauritius, the region, the hemisphere, and whether it's a primary site or secondary site or tertiary site. So now we have access to a lot more data, which means that we can potentially filter for a lot more things. So I'll just turn these off. And the first thing we're going to do is spend a little bit of time talking about the F object. So if I just scroll up slightly, first things first is you'll notice that this filter is prepended by this letter capital F. And the F function allows us to do more powerful filtering. As we go through the demos, we'll progress through it in terms of complexity. But I would just like to point to your attention and notice the differences as I'm showing them here. So if we go over to the GitHub repository, what I'm going to do firstly is show you this cheat sheet that I've developed. This cheat sheet is a really powerful tool and is here to help both you and me remember what we can do with nornir filtering. So we have documented all the logical operations that we can achieve. We'll go through the majority of these in the demo, but all of them are listed here, and examples of how to actually use them are listed here below. So we'll start off with the filter hemisphere function. And in here, what we're going to do is introduce the F function. And what we are doing here is we are using an operator to filter our inventory. So what we are doing here is we are going to filter for a hemisphere, and the hemisphere has to equal exactly what is supplied in at the top of the function. So just to reiterate, this double underscore is used, it's, I believe, a special Python method, and that's the way that we let nornir know that we are using these object operations. So we're going to use the equals operation here. So let's turn off this filter function. So sorry, let's uncomment the filter hemisphere function. And what this is going to do is basically filter the entire inventory for anything that has the northern hemisphere. Okay, so as we can see, it's come back with some hosts and it's come back with the hemisphere. Now, if we have a look just quickly at our host data, you'll see in here that we have not specified a hemisphere. And what we've done is we've used, if we look for say DFJT R001 lab, you'll see in here we have not set the hemisphere. And what we've done is we've actually set the hemisphere on the site code. So if we go over to the groups file, we see in here that we have a site code called BCN, which is Barcelona, and it's in here that we've set the hemisphere. So this really shows how we can layer our inventory, and we can be really smart with the way that we inherit group configurations all the way down to the host, and really start to develop a structure for our network environment and make sure that we're being as efficient as possible with not repeating ourselves and putting duplicate data in multiple places. Okay, so now we've just seen a basic equal, and we're going to do the similar thing again. This time we're going to do filter for every single device which has the site code of MTL, which is Montreal, and we're going to print that out to the screen. As you can see, we have 3 devices, so not too different to this function, except we're just filtering on a different property. Next, what we're going to do is introduce the not operator. So if you compare this function above, these functions look identical except for this tilde symbol here. And what this tilde symbol does is basically do a not or an inverse match of whatever is inside this uh, f this f object operator. So essentially what it's going to do is filter the inventory and not show anything that is equal to the site code that we pass in. So basically it's going to filter and display everything in the inventory that does not have the site code of Melbourne. And as you can see here, we've got Barcelona, Montreal, Port Louis, Christchurch, and we're not seeing any Melbourne entries. This is the first point that we've reached at in the demo where we've seen the actual value of using the F object. Up until now, we've been able to do everything that the basic filter can do everything up until this point. And it's at this point, as we go through the demo, you'll start to see the value of using the F object operator. So now let's start moving a little bit faster. What we're going to do now is introduce the OR operator. So what we're doing here is we're filtering in 2 site codes, and what we're going to do is if the site code equals site code A or site code B, then this is what we are after. So let's run it now. And now we are getting back hosts with site code of Port Louis or Christchurch. This next function shows how we can use the not operator, again using the AND operator as well. So what we're going to do here is we're going to filter for devices that are not a switch and, which is the AND operator, not a router. So let's run that. And as you can see here, it's only displaying firewalls. Okay, let's move on. Next handy filtering option is this option of children of group. So what we can do is we can filter the entire inventory to find the children of a certain group. So again, using the inheritance to find exactly what we're after. And what we're going to do here is we're going to feed in the environment of test. sorry, the group of tests, and we're going to find the children of that group. So let's run that. As you can see here, we have these devices. So now we're going to move on to some more object operations and see what else we can do with regards to providing more scientific filters. At this point, I'm going to introduce the greater than or equal to operator. So what we can do is we can filter based on the SLA, and what we're going to do is filter on the SLA is greater or equal to a certain value. So before we do that, I'll just bring up the groups.yaml file. And as you'll see in here, we've got, not every single group has an SLA, but these three that have SLAs, one being production of 90, test of 80, and lab of 70. So what we're going to do is filter for devices that are greater than or equal to 80. And as you can see, we don't have any lab devices printed to the screen. And I also went to the trouble of printing out the production value as well. Okay, moving on. Now we are going to look at another object operator, which is the any operator. So what we can do with the any operator is we can feed in a list, and if anything matches anything in that list, it will match the filter. A really good use case for this is doing something like filtering for a certified OS version. So imagine in your environment you have multiple vendors or multiple switches or multiple trains, and you have, approved OS versions within inside your environment. So what we're doing here is we are going to use this list called the version list, and we are going to filter for any occurrences which match what's in this list, and that will be shown as a certified. That will match the filter, and then that will be displayed to the screen. So let's run that function now. And as you can see, the devices print to the screen match what's in the filter. We've got 16, 6.4, 423, 2F, etc., etc. And obviously, if we can filter for things that we want to match, we can just use the tilde function to filter for things that don't match the certified versions. So let's run that now. As we can see, these are the ones that don't match this certified OS version list. Next, what we can do is we can use inside the groups.yaml file, we have this concept of production equals true and production equals false. So again, we've got some business metadata tags that we can take advantage of when we're filtering our inventory. So what we're going to do now is filter for production equals true. So you can see the value of using groups and hosts and setting business metadata inside your structure, because then that way you can filter for what it is that you're after. What we're doing here is we're taking the output of this function, which is non-certified devices, and we're feeding it into a second function. So we saw this setup in the intermediate filter section, and that's all we're doing here as well. So what we're doing is we're now finding devices in production which are not running certified versions. Okay, let's turn these off. Again, because we went to the trouble of setting all this metadata about our site codes, we can start to exploit that with our filtering. And in this example, we're just going to filter for all APAC devices. So we've got a couple of sites here that are in the APAC region. So we would expect to see these come back inside the filter. Okay, cool. So you can see that there's some devices in Australia and some devices in New Zealand which have come back from the filter. Okay, what we're going to do now is we're going to move on to the last type of filter and probably the most powerful one, which is filter functions. Nornir offers the ability to write your own functions and based on, a true or false match, uh, adding those to the filter. So what we're going to do here is we're going to go through a couple of basic examples, although powerful examples of how you can use filter functions. The first one we're going to use is this filter odd devices. So what's actually happening here is we're going to execute this function, filter odd devices. Filter odd devices is actually going to call another function called odd device naming convention using this filter func functionality. So what I'm going to do is scroll up in the code and I'll bring them side by side. So as you can see here, we've got filter func odd device naming convention, and on the left hand side here is the name of the function. And what this function is going to do is basically do a regex match based on the host name, and based on it matching a certain regex pattern, it's going to return true, which means we're going to add it to the filter, and if it returns false, it will not be added to the filter. For those of you that don't know regex or don't know how to use it, it's a very powerful tool. I suggest that you make attempts to learn it. It's highly valuable skill to have as a programmer and just as a network professional in general. So if I was to break down this regex filter, the dot plus is basically matching a whole greedy string, and the same thing at the front here. And if we look at the example shown and documented inside the function, essentially what we're trying to do is match on these two interesting values. And basically, if the first digit is 0, the first digit can be anything. So it can be, 1, 11, 21, 31, 41, etc. And then the second digit we are matching has to be an odd number, which is defined here. So if we go and have a look at our inventory, we've got even. We seem to have a loose naming convention here where we've got a rough device name format, although it's not universally consistent. But what we're trying to match is essentially here. And if that's true, we'll return the device back through the filter, and if it's not, we won't return it. So what we'll do is we will run that function. And as you can see here, they're all matching a certain pattern. They're all ending in odd numbers. Okay. Next one is the even devices, which is literally just, the reverse of what I just showed, which is just, 2, 4, 6, and 8, and they're identical except for that. And I will run that function now. Okay, and as you can see, only even devices are returned back. So let's move on to another really good use case for filter functions. As I showed before, we seem to have a loose naming convention whereby we have, an environment, the type of vendor, and then 2 digits, and then we have this 3-digit code, and then, a suffix basically here, and the 3-digit code appears to change depending on the type of environment, roughly speaking. So what we're going to do here is we're going to just have a look at that code. So filter device naming convention, sorry, filter test domain devices is going to call test domain name convention. So let's go and have a look at this. So again, we're just using regex, and what we're doing is we want to match anything that ends in the suffix test.dfjt.local. So we've got a few examples here. So let's go down and run that code and see what we get back. As you can see, they all end in the correct suffix. Okay, so next, one that I really suggest developing for your own environment is a device name naming convention. So again, what we can do is we can uh, make our own filter function. Uh, and what I'm showing you today is just using regex, but you could literally write your function to do whatever it is that you want. I'm just showing you how you can use regex to really, I guess, supercharge the way that you look for things for filtering. So this function, again, seems to be looking to find devices that adhere to a certain naming convention. So we are trying to match 3 words or 3 letters, then a hyphen, then this particular string here varies in length and is not actually consistent within the inventory that I'm showing you today. So sometimes it's 4 characters, 3, but it's a word and it's a certain amount. And then it is delimited by a hyphen. Then we have 2 digits that we're trying to match. Then we have a dot and then 3 words, and then everything should end in dfjt.local. So obviously this would depend on your environment, but I highly suggest developing your own filter function for this, and you'll see the reason why now. So we have 21 matches, and as you can see, they all adhere to the naming convention as shown in the regex filter. Interestingly, we actually have 27 devices in our inventory. So what we can do here is look at devices that don't match the naming convention. And so if I just go up in this code here, um, this is the exact same regex match, but what we are doing is we're simply inverting what we are returning. So over here, we are matching for the same thing, but we're returning true. So all I've done is inversed what we are returning. So anything that matches this would be false, which means it matches the naming logic, and anything true would mean it doesn't match this. So again, let's run that one and let's see what we've got. Okay, so we've got a few that have come back. Some that are pretty obvious, like this one doesn't have 3 blocks of text in the name, so that's pretty easy to identify. This one here has 3 digits instead of 2. And this one here has, for those who are eagle-eyed, it has DJFT instead of DFJT. And again, over here, this one has 4 words before the first hyphen. So this is really powerful, and hopefully this gives you some ideas of how to use filter functions with inside your environment. Okay, so next what we're going to show is filtering based on site type. And what we're going to filter on is the primary site type. So before we do that, let's just quickly go back to our inventory data again. And in our host inventory, we're not setting the site type, but over here on our site codes, we're setting the site type. So as you can see here, modern network environments are based over multiple sites over multiple regions. Uh, and you might have a primary site for the APAC region, you might have a primary site for your Americas region, you might have a primary site for your Mauritius region, sorry, for your EMEA region. And really what this is here to show is, you know, you don't always necessarily get, you know, 3 of each in every single region. A lot of companies only have, primary, secondary. If they're an APAC based company, they might have primary, secondary in the APAC region, and then they might only have one site in Montreal, as an example. So what we're doing here is we're filtering on site type equals primary. And as you can see, that's set across 4 different sites. So by layering our metadata in a certain way, we can then just use filters to find those devices. So let's run that. And as you can see here, we've essentially filtered and found every single device that's at a primary site, irrespective of what region or what actual site code it's at. Next, what we can do is do the inverse of that. So we can use the any operator, which we saw before, and we can filter for sites, uh, any site that is inside this list, which is tertiary or secondary. So basically anything that's non-primary. So let's run this again. And as you can see, it's brought back our other sites. Okay, so now to wrap things up, what we're going to do is we're going to chain some filters together and we're going to try and answer, a business specific filter using nornir filters. And really what this is here to show is you can literally cut the data or cut the filters whatever way you like to actually find what it is that you're after. So I'm going to move through these quite quickly because we've already seen some of them before. But just to recap, what we're going to do is we're going to run a function and assign it to a filter. Sorry, assign it to a variable. Then we're going to feed that next variable into the next function, and then we're going to assign that to a variable. And basically, as we work our way down here, we're basically taking the output of this and putting it into this, taking the output of that and putting it into that, etc., etc. So firstly, let's filter for odd devices. So we want to find all odd devices across the environment. Apologies. So we've got 15 odd devices. Next, we want to filter on devices which are compliant with the device naming convention. And now we're down to 13. So we've whittled out this device and this device. Okay, now we want to filter again. This time we want to filter on compliant devices with an odd name in the APAC region. Okay, so now we've got these devices. Now we want to filter on devices which are not in a primary site type inside the APAC region. And now we're down to 2 devices. So they're both based at Christchurch. Now what we want to do is filter for those devices and check which one is actually running a certified OS version. And so as you can see, we started out all the way at the top with odd devices and we've slowly whittled down our filtering and we end up with a device that has an odd name that's running a certified version of software that's in a secondary, not in a primary site type, that matches a compliant naming convention and is based in the APAC region. All that with the power of nornir filtering. Thanks for joining me in today's video. In today's video, we covered nornir filtering. We started out with basic filtering. We moved through the different filtering types with the basic filter, the F function, and filtering functions. We also briefly saw how motherstarter can assist us in generating our own inventory. We also learned important lessons about having a structure for your metadata and also populating as much metadata about your network devices and your overall environment. By having access to that data, we can be very scientific with our filtering queries, and we can literally filter for any device combination or permutation to target the actual devices that we need to target. Thank you very much for tuning into this video, and if you'd like to see the demos or run the demos yourself, all the code is contained within this repository, of which you can download and follow the installation instructions and go into each demo and follow along with the code there. Thank you very much for watching today and have a great day.